Hello everyone, my name is Dan the Tutor. This is the second part of a two-part video where we cover systems of equations. In part 1 we covered the elimination method for solving, and today we're going to be covering substitution method. So first it's important to know that when is it a good idea to use the substitution method? And you'll know it's a good idea when you have something like this. X equals 6y minus 11 and x plus y equals 10 or whatever. But one of the equations is already in the form x equals. That's a dead giveaway. We want to use the substitution method. Now in terms of solving using substitution method, let's get into our first real problem. And that is x equals 6y minus 2 and 4x minus 10y equals 6. So it looks like we're already in the form of x equals here. We're happy. And now what I need to do is I am going to substitute. And when I say substitute, I mean plug in this x, this 6y minus 2, into that x in the second equation. Let's see what happens when I do that correctly. I'm going to write, for the second equation, I'm writing 4 parentheses 6y minus 2 minus 10y equals 6. That's what substitution looks like. The reason why this is a good idea is because now look, I've went from having an equation with two variables, x and y, I'm now down to only one variable, which is y. And that's why this strategy works so well, because we can solve this now. So the next thing I need to do is distribute 4 to both terms. That's going to give me 24y minus 8 minus 10y equals 6. And now I need to combine like terms, which is the 24y minus 10y. That's going to give me 14y minus 8 equals 6. If I want to solve for y, I need to add 8 to both sides. So that gives me 14y equals 14. Divide both sides by 14. We'll get y equals 1. There's one of our answers. Now to find x, just like the elimination method, I need to plug in that value for y back into one of my first two equations. So it doesn't matter which one I plug into. I can choose the first one or the second one. I'll choose the first one because it looks easier. So x equals 6y minus 2. I'm saying y can be plugged in right there for 1. So x equals 6 parentheses 1 minus 2. 6 times 1 is 6. X equals 6 minus 2. X equals 4. So my solution is x equals 4, y equals 1. Or if you want to write it like a coordinate point, because some teachers want you to do that, then you get 4, 1 as your answer. So that's substitution method in a nutshell. Here's the next one, which will be a little bit harder. Let's say I have as the first equation x minus 5y equals 17, and for the second equation 2y equals 4x minus 32. So first I need to choose which equation I want to use for the substitution, and I think it's safe to say that we want to use this one because it's already in the form of y equals. But there's one problem. I can't work with this equation because I have not y equals but 2y equals. So what I need to do here is say, okay, well let's divide everything by 2. When I do that, now I just have y equals 4 divided by 2 is 2 and then x, and then negative 32 divided by 2 is negative 16. There, now I'm in the form that I want. And I can plug in this y into my second equation by plugging 2x minus 16 in for that y right there. That's what substitution method tells us to do. So I'll have x minus 5 parentheses 2x minus 16 close parentheses equals 17. Now I just need to distribute the negative 5 to both things. I'll get x minus 10x, and then negative 5 times negative 16 is positive 80. And if you don't believe me, you can check your calculator. And that's going to equal 17. Once again, I need to combine like terms. X minus 10x is negative 9x plus 80 equals 17. I need to subtract 80 from both sides. That will give me negative 9x equals negative 63. And then when I divide both sides by negative 9, I get x equals positive 7. So there's one of my answers. And once again, if I want to find the other answer, then I need to plug back into one of my original equations here, one of the top two, one of these equations right here. Or alternatively, I can also plug into the equation when I divided both sides by 2. That's acceptable as well. And as a matter of fact, that's probably the easiest one to use, so I'm going to use that one. Y equals 2x minus 16. y equals 2x minus 16. I'm plugging in the 7 for that x right there. So y equals 2 times 7 minus 16. Y equals 14 minus 16. And then y will equal negative 2. So the solution is x equals 7, y equals negative 2, or as a coordinate point, 7 comma negative 2. There we go, easy peasy. And now the third problem I have for you today is definitely going to be the hardest. It will have some fractions in it, but that's okay because we like fractions here at Dan the Tutor. And if you don't, well then you can just stop watching the video. I'm just kidding, please keep watching. So for this one, I'm definitely choosing the top equation for the substitution because it's almost in the form y equals. I just need to divide everything by 3. And here's the annoying part, because 4 is not divisible by 3, neither is 11. I do not want you to convert that to a decimal. I want you to keep it as a fraction, and there's a very good reason for that. When I do this, I'll get y equals 4/3 x minus 11/3. And this is fine. We're not complaining. But now I need to plug in this y into the second equation like this. And when I do that, I'll get 8x plus 3 times the parenthesis, 4/3 x minus 11/3. That's equal to 13. Maybe you see why it's not such a big deal right now. Because the very next step, I'm going to distribute this 3 to both terms, and anything times 3 with a 3 in the denominator will cancel out the 3's. So in other words, when I simplify this, I get 8x plus 4x minus 11 equals 13. See, that wasn't bad at all. Now, I'm sure you're wondering, will that always happen? Will it always cancel like that? No, not always. But at the same time, I don't think you're going to see that difficult of examples because your teachers aren't that evil. Some of you would disagree with me. But most of the time, I'm even going to say all the time, they should cancel out in some way if you have a fraction. So now I'm combining like terms. 8x plus 4x is 12x minus 11 equals 13. Add 11 to both sides. We get 12x equals 24. And then divide both sides by 12. And you get x equals 2. Now we already have done this a million times already. But one more time I have to plug in x equals 2 into one of my original equations. I think I'm going to choose the second equation because I don't want to deal with fractions. So 8x plus 3y equals 13. And I just need to plug in that 2 for that x right there. 8 times 2 plus 3y equals 13. That means we'll get 16 plus 3y equals 13. Here I'm going to subtract 16 from both sides. I get 3y equals negative 3. Divide both sides by 3, and we'll get y equals negative 1. So x equals 2, y equals negative 1, or as a coordinate point, 2 comma negative 1, and there's our answer. Now I'm sure some of you are wondering out there, just like we had for elimination method, what will it look like if I get no solution or infinitely many solutions? That will look like something like this problem. If I have x equals 2y plus 6 and 3x minus 6y equals 18. So for this problem, I would substitute in x for that equation right there. I don't even need to divide by anything, so that's nice. I get 3 times the quantity 2y plus 6 minus 6y equals 18. When I distribute the 3, I get 6y plus 18 minus 6y equals 18. The 6y's will cancel, and I get 18 equals 18, which is a true statement. This is when I get infinitely many solutions. And if you wanted to know what no solution will look like, it will almost look like the exact same thing, except instead of ending with 18 equals 18, you'll get something that's false, like 18 equals 9. And that's not true. And when this happens, you get no solution. So that's what that will look like for substitution method. And finally, one more thing I want to say. How do you know if you should use elimination or substitution method? It's as simple as this. If I have my equation set up like x plus y equals 6 and 2x minus 3y equals 10, where the x and y are on the same side for both, this is when you want to use elimination method. Substitution method you want to use whenever one of your equations is in the form x equals, like x equals 6y minus 11, and then the second equation doesn't matter. I can have y minus 3x equals 10, but as long as one of the equations is in the form x equals or y equals. And that's it. I hope you all enjoyed this video. Keep on practicing these problems. The more you practice, the better you'll get. So I hope you all have a great rest of your day, and I'll see you next time. Bye-bye.